Good afternoon, everyone. People present in person and people present online. Good afternoon. Sorry for the couple of minutes delayed, but we still have to live with load shedding. But eventually we are back. Yeah. So good afternoon, everyone. My name is Francesco Petruccione, as it is usually. Yeah. So welcome to this edition of the NITheCS Colloquium. Today we are very fortunate to have Dr. Anwar Vahed with us. Anwar is the director of the Data Intensive Research Initiative of South Africa, also familiarly known as the RISA. Yeah? And before having this prestigious job, he had various other positions at the CSRR, but he started his career as a director of the computer science department at the University of Western Cape, so not far from here. So this is a home game. Yes, and Anwar is here today because he developed the big data, the national big data strategy and research development and innovation plan, yeah, and is here to share with us the objectives and the goals and the implementation strategy of this new strategy that should be of interest to all of us that have something to do with small and big data. So Anwar, we are very glad that you are with us this afternoon, and please, over to you. You're most welcome to start your presentation. Thank you very much.
Thank you very much, Professor Petruccione, for inviting me and for opportunity to present. So my presentation is decidedly non-technical. It's about a strategy. It's part of my responsibilities as director of DIRISA, as Professor Petruccione mentioned. I was requested by DSI some year or so ago to develop what they call big data strategy for the country. And so this, most of this presentation will be about the strategy, but the last important aspect of it is the implementation aspect. So there is an implementation plan as well. And we are in the process of conducting, executing that implementation strategy. And so the relevance for this kind of presentation is to I was told that DIRISA and the strategy are two of the most well-kept secrets in the country. And so I should go out there and advocate and present it. So this is one of those opportunities. So thank you for that, Professor. So this is an outline of the strategy. You would probably know a few years ago, big data was the trending issue. According to Gartner, it's now past the peak of hyperbole, and it's now fading away if you look at the Gartner curve for the big data. But it hasn't gone away. In fact, big data is growing at an exponential rate. And one of the concerns that we have is that big data is now going beyond what we can think of as the traditional disciplines like astronomy and bioinformatics, climate change. It's now showing itself as a challenge in other, let's call it non-traditional disciplines like the humanities and social sciences, where the big data is becoming an issue as well. And as far as artificial intelligence goes, which is a trending issue right now, big data is sometimes confused, and it's sometimes put next to AI. It's not a technology, it's an event or a phenomenon. And actually, big data is one of the infrastructures that you need to perform artificial intelligence. So this year, my presentation outline. And towards the end, I'll speak about what we are doing at the moment and how far we have progressed with this strategy. So this slide shows the process that we followed. We started out with a draft of contributions by international experts. We consulted similar organizations globally. UDAT, the European one, ARDC, I think they've changed their name, but that's the Australian equivalent of DIRISA out there. NIST, National Institute of Standards and Technologies, is in the United States. JISC is in the UK. So there were contributions by these international experts to the strategy. We then got input, feedback from other stakeholders locally. There were a number of workshops that we conducted. And finally, the strategy was published for comment by other key stakeholders. So that's in broad steps is the process that we followed when we developed the strategy. I think big data doesn't need much description. I think everybody's aware of some of the attributes that is usually used to characterize big data. We've added some new, well, not new ones, but other ones that we thought was important. And of the lot, I think value is probably the most important one. And what was asked by DSI was for us to expand this definition of or the attributes of big data and to focus on value, simply because there's a lot of data, historical data, that's got important cultural significance and historical significance. And so we've taken a little bit of a broader perspective of what we consider to be big data. We also excluded, well, not excluded, but distinguished between what we call extreme data. That would be data generated that are orders bigger than what is normally generated, such as the SKA and the CERN experiments. So that we kind of put aside, we distinguish between that and what big data would normally be considered to be. So the challenges of big data is also fairly well known. The problems start right away when you try to acquire or generate big data, and then immediately you have issues with storage and those kinds of things. But the technology is actually the easier part of these challenges. So scale, heterogeneity, and complexity, those are issues that your traditional computer scientist or IT person can deal with. But there are other issues from a national perspective that's much more important. That is, number one is, in South Africa, we don't have enough expertise to deal with big data. Human capital is a big issue. Cyber infrastructure, we don't have enough infrastructure to actually manage big data. To give an example, the SKA will generate about 20 or 30 terabytes per day. If you add that up, then all the storage locations that we have in South Africa will probably suffice for about 6 months, and then it would be filled up. So cyber infrastructure is a big problem. And then, very importantly, ethics and privacy. And the thing with big data is that your traditional statistical approaches are not always appropriate. And then with bigger data sets, there's a bigger chance that you can actually de-anonymize, de-confidentialize what used to be anonymous data. For example, if you combine your Facebook and your Google data and some other data, Twitter, whatever, it is possible, especially with AI, to actually de-anonymize a person, like in the picture shown here. in this slide. So there are quite a number of problems that to date have not yet been solved, especially in the non-traditional disciplines. And these issues go along the entire uh, processing chain, if you like, for big data. Of course, there are opportunities, and I think we are well aware of those in what I call the traditional sciences, like astronomy and so on. And as I mentioned, it's now becoming a challenge also in other disciplines like the social sciences and the humanities and so on. But there are lots of opportunities, and the big issue, especially for South Africa, is that we don't really exploit these opportunities. And the strategy is all about how we should go about and how we should position ourselves to actually leverage these opportunities. So, the purpose and the scope of big data strategy, as I said there, it's about really establishing a more competitive socio-economic environment for South Africa. But importantly, the strategy is limited to research data only. Reason for that being the private sector is not very keen to share information about their big data resources, and you can understand that one wouldn't expect Standard Bank to tell us, oh, this is how we deal with all the millions of transactions that come our way, or the Department of Defense or environmental studies. They wouldn't say to us, well, this is how where the rhinos are in South Africa and our nuclear warheads are there. Well, we don't have nuclear warheads anymore. So it's difficult to get information, especially from the private sector. And the other big source of big data, of course, is social media, which is very difficult to control, simply because we're not owners, we're not stewards of those kinds of data. You can think Facebook, Twitter, and so on. So the focus and the scope of the strategy was just on research data, simply because that's where most of government's spending goes. And you'd be surprised to see how much money is put into the collection of data. So that's the purpose and scope. We also decided on a number of principles. The strategy should be inclusive. It should take care of issues of privacy and ethics. There should be a good, strong, coherent governance structure for it with clearly defined roles. And then there are those two abbreviations: fair, free, accessible, interoperable, reusable, and care, which is another important principle: collective benefit with authorities control. This care aspect or principle is actually very important when we think about indigenous knowledge. Very important in the sense of sovereignty. Question that you have to ask there is, who's in control of your data? If you put it at what's it, OneDrive and Dropbox and Google Drive, who's in control? And that's an important question, especially when it comes to big data. The objectives of the strategy, there are 5 of them. Most importantly, to develop human capital, simply because we do have a dearth of expertise in South Africa to put down, set up the necessary cyber infrastructure to manage, process, analyze, visualize, distribute big data. Then collaboration, very important aspect. And then data governance, which includes data stewardship. The problem with most data is that ownership and custodianship and those aspects are not very well defined. And we very often we lose data because nobody's really taking care of it, looking after it. And institutions are waking up to that. Universities are establishing their own data repositories. There are requirements, especially abroad now, that when you submit your master's or your PhD thesis, you must also say where the data is and what the processes are. So it's becoming an issue. It's becoming an important issue for data in general, not just for big data. And then lastly, as was requested by DSI, to have some sort of a structure that oversees the implementation of the strategy. So the next few slides is about implementation. It's about actions, the framework of actions as it's defined in the strategy, and some indicators of success. But this slide here basically shows, it's a summary of how the inputs and enablers for big data will eventually culminate in some impact. I'm not going to go into the detail there, but the most important step right now for us is the layer right at the bottom. Skilled and expert human capital, the technology infrastructure, and then of course funding and stakeholder involvement. And the intent, of course, is that once those things are in place, we will be able to achieve those outcomes, outputs, and eventually the impact of the strategy. So coming to implementation, the strategy identifies 18 different actions. All of them are categorized under one or other objective. So there are the 5 objectives, and that's used to categorize some of the actions. And what you see on the screen here are the most important ones. What we think are the most important ones, as I mentioned already, human capital development. One idea that came up was the establishment of something like the Turing Institute in the UK. I think we have something like that already, and we will probably leverage that kind of structure to see how we can fast track human capital development. Then we will try to identify what we call collaborative flagship projects. And these flagship projects would be R&D that focuses on specific national priorities. And you can think of poverty alleviation and so on. Then we think that sustained investment in the provision of a cyber infrastructure to support big data analytics, big data dissemination and storage and management. That's important. And in today's climate, we also feel that policies and a code of conduct, especially with the likes of AI trending now, is becoming very important. And then lastly, NITheCS, which is a National Integrated Cyber Infrastructure System, will be the implementation agent for the strategy. There are 16 indicators of success in the strategy. And what you see here, listed here, are probably the most important ones. Second bullet, the number of masters and doctoral students going through the system, number of postdoc big data researchers, and so on. Most importantly, we need to see impact. And the 4th bullet and the 5th bullet, that relates to impact. We would like to see, for example, big data outputs and outcomes serve in some or other way the needs of South Africa. So the implementation, what we're now busy with right now is we are conducting a survey of existing activities across all universities, all research institutions, research councils, and even government entities concerned with big data research. There's a Google form out there asking questions about the HCD capacity and activities at various institutions, R&D activities, and resources. And we hope that the outputs of this, the findings from the survey, will help us to develop a call, R&D call, for potential collaboration, not just among universities, but also involving the public and private sector as well. We're also in discussions with some universities and other organizations, and the idea or the intent there is to see how we can integrate this effort with other similar kind of efforts across the country. And then we are busy upgrading the NITheCS platform. I'm not sure whether you're aware of the Center for High Performance Computing, a big component of what we call NITheCS, providing the necessary cyber infrastructure to support big data research. So that is my presentation. Thank you very much, Professor.
Very much, Anwar, for the nice overview. I'm sure we'll have plenty of questions, and maybe we can start in person and then ask the colleagues online if they have questions. Any comments or questions from the audience here? Please.
When you speak about training up human capital, is that now specifically like in the data processing, or is that like all-encompassing data processing, collection, maintenance?
We've identified 3 different categories of human capital needed. One is the technology expertise. That would be the resources that you need to develop, maintain the necessary technologies supporting big data. The next one is, or next category are the data custodians and data stewardship people, your librarians and so on. So you can think of that as the soft side of the kind of capital or the kind of resources that you need. And then the third one would be the engineers, if you like, or the practitioners who actually utilize the resources to develop new outputs from big data. So those 3 categories.
Hi, I was wondering, you mentioned early on in your presentation about historical data, and I was wondering if CSIR has got anything in place or plans to have anything in place to help with the digitization of that, because I think that's a big backlog in terms of some of the historical data that's in South Africa. I'm from an ecological background, and we have a lot of data on rhino locations and things like that that need to get digitized, but the capacity and infrastructure isn't there.
Yeah, no, that's exactly what the historical data is about. There's basically 2, if you want to categorize or type them, there's historical data of research significance and historical data of cultural significance, our history. Basically, our history is in data. Data contains our history. So there was a request from DSI to also include that, and that's why those attributes include under value also include historical data. So to give an example, the Department of, I think, Water Affairs had 30 years of dam level data, which they lost. And the implication of that is that how do we respond to issues like climate change? How do we track and build trajectories or extrapolate if we don't have that data? So there would be data of historical significance And as you rightly say, there's a lot of environmental data. There's a lot of Earth observation data. There are sets of longitudinal data about urbanization, for example. And if we don't take care of that, it will severely compromise the kind of research that we can do in future.
Yeah, yeah. Yeah, thank you very much for interesting presentation. This question might be a bit naive, and forgive me if it is. Since the concept of big data is relatively recent, how does one decide who is currently an expert of it and who isn't? I understand the development of human capital requires also thinking of what education to provide and so on.
Yeah.
So right now we need experts of big data in order to do that.
Yeah.
And how does one decide that? Who is considered as the expert of big data?
Okay. All right. Yeah. So there's a bigger overall issue, and that is data. You know, big data is a component, albeit a very prominent component of data. And on the governance side, there is movement in the sense that there are strategies and frameworks and policies pertaining to data in general. So the big data expertise would be a component of what we would consider to be the data sciences. And a cop out of your question would be, okay, what is data science? And the question came out, especially at our institution, CSIR. And I think the outcome is that data science is basically a conglomeration of traditional subjects like statistics, analytics, computer science, technology, mathematics, and so on. So it's a different combination of those disciplines. So if you want to call yourself a data scientist, for example, you need to know a bit of statistics. Now, if you extend that to big data, it means you probably have to know something about statistics concerning big data. The issue here is your traditional statistics. I'm just making an example of, for example, anomaly detection. It works fine for small data sets. But when your data size explodes, then the needle in the haystack, there are so many more needles. And so you need to have a different and fresh approach in, for example, statistics. Similarly with storage, that's another example. We cannot possibly store, for example, all the data generated or to be generated by, say, the SKA or even CERN. It's just impossible. So decisions have to be made about what you keep and what you throw away and how to compress it without losing a lot of information. And the astronomers tell me that 80% of their data is noise. The problem is they don't know which 80%. So there's a new question, research question here that has to be answered. And that is, how do you deal with data sets that are orders larger than your storage locations? So those would be big data science questions. Similarly with analytics and with visualization, if you go along that chain, you can now identify new problems specific and particular to large volumes of data. Another aspect that I haven't mentioned at all is the heterogeneity of data. You've got images, you've got unstructured data, you have text, and so on about the same thing. So how do you combine that? Another big data question, and we're looking to you to answer this.
We have a question online by Peter van Heusden. Peter, you should be able to unmute yourself and ask your question.
Thanks a lot, Prof. So yeah, Anwar, firstly, looking forward to your next visit to UWC. And it's my question, look, I really like seeing that the public sector is mentioned in big data terms. In fact, public sector data was crucial in responding to the COVID-19 pandemic. But one challenge has been that government is not easy to deal with from a research point of view, and working with government big data means coordination with the government's own data strategies at the different, municipal, provincial, and national level. How are bridges being built, and do you see that this is a role for that coordination that you mentioned there at the end?
Yeah, it's exactly that, Peter. What we've got are different repositories or resources of data. On the one side, you've got, we call it primary research data. Primary because that's the initial purpose for which the data was acquired or collected or generated. Then you have what we can call secondary sources of data. That's what government collects sometimes and what other companies collect. And the ideal would be to combine all those data collections, if you like. So we do understand that government cannot make all their data open or accessible. You don't want somebody to see what tax you pay every year, and so on. So there are limits to or constraints on what data can be provided, what data can be made open and public. But under ideal circumstances, we would have data sets or data collections from government resources. We just need to manage it very well. And we would like to combine that with the traditional research data collections that we have.
Thank you. There's another question online by Kerstin Jordan. Kerstin, please.
Hi, can you hear me?
Yes, we do.
Okay. Yeah, my question is linked to the one by Peter. So thanks for the very interesting presentation. What I am still missing is, in terms of government data, what already is available, what the structures are that are responsible for actually ensuring that this data is, that it has good integrity. I can give an example. The latest data set by the Department of Basic Education on schools. We've done an analysis on just the basic location of the schools. So once you clean up the data to just get all the commas, etc., in the notation right, there's still a huge discrepancy. Out of the 26,500 schools, about 7,500 of them are located west of Africa. That can be explained by just the longitude and latitude being wrong, but it just shows how flawed the data is, because when one tries to use that data to actually contact schools, which the South African Mathematics Foundation really would like to do, there are so many errors that you just cannot contact the schools based on that data. So if you go back to the older data sets, they actually are more accurate, they have less flaws. But so who's responsible for making sure that this government data that is open access is actually of good enough quality that one can use it for research or whatever else you need it for?
Yeah, I think probably a knee-jerk response to that question is that every government department collecting or responsible for data on a specific aspect that's relevant to what their existence is about, they would be responsible for, I think the issues that you are mentioning concerns the integrity, the provenance, and the quality of data. I am aware of a quality standard that has been developed by Statistics South Africa, which supposedly has to be implemented government-wide. But like any other, or like many other data sets, it's really difficult to pin down, I think what you're mentioning are quality aspects of data. And the best way to probably do that is to look at the provenance, the lineage of the data. Where does it come from? How was it obtained, and so on. But from our perspective, for example, Teresa, we adopt what we can probably call a black box view of data. We don't open the box and look inside and see how good the data is and what the quality of the data is. But in terms of big data, that becomes a very relevant issue, because we do know that if you combine different data sets about the same issue, then you can increase the quality of the data and the integrity of the data. I don't think I've answered your question, but that's my best response.
Very much. Can I also ask you a question? You mentioned at some stage big data in the context of climate change and so on. Is part of the plan also to increase the number of sensors that we have scattered across the country to collect
Yes,
data for climate change, for instance?
there's a plan that goes beyond just climate change, and that is what we call a national architecture for data processing nodes. And the idea there is to establish consortia of institutions at different places, regions in South Africa, focusing on different disciplines. And the framework for that is a kind of a national nodal architecture for cyber infrastructure resources. So there might be a node in, say, UKZN, focusing on health and medicine, and another one in another area, another province, focusing on different aspects.
Thank you very much. Maybe one last question, please. You have a microphone. You have to ask something now.
Thank you so much for the talk. The question was asked already, kind of, but what are your so Stats SA and other organizations have obviously collected a lot of data, but in my experience, it's quite hard to find, as well as it's also international institutions' data is contradicted. How do you reconcile it? Or like when you're, do you plan to create a bridge between those two?
What we're thinking of and what we are trying to establish is called a federated data system. And this federation will then incorporate custodians of incorporate other repositories. Let me put it that way. The Stats SA, they have their own repository. The idea is not to take the data over or to store it or to manage it. But what we would like to do is provide a link to it, which is a fairly easy thing to do. But there are underlying arrangements that you have to have. There's a memorandum of agreement, there's confidentiality issues and those kinds of things which happen at high level. But the ideal or the dream is to federate all sources of data. And so you can have a one-stop shop where you can get research data on Earth observation, satellite data, health data, and other subjects. And the idea here, it's a very ambitious one, is to have this one-stop shop which NITheCS can then provide to the researcher. Still long to go. And visibility of data is an issue in general.
I know that Anwar needs to catch a plane in less than 2 hours. So I think it's probably an appropriate moment to stop the colloquium for this evening. So Anwar, thank you so much. And hopefully in a few months, we will invite you again to hear how the implementation plan goes. and also maybe to learn more how we can get involved with all these interesting activities. Yeah.
Thank you.
So from all of us here and online, thank you very much, and safe flight back home. Thank you.
Thank you.
Very much.